Hello all and welcome back to physics. I apologize if you hear some traffic sounds going on right now. They are doing construction outside of my house and there's not much I can do about it. Today's lesson is how to solve for velocity. We talked a little bit last week about the vocabulary of motion, and just as a review, velocity is the change in distance over a specific change in time. If we were to write this as an equation, we see that velocity is the change in distance divided by the change in time. If we're going to write this out, because remember those triangle symbols, the deltas, mean change in, that means we have the final distance minus the initial or starting distance divided by the final time minus the starting or initial time. Okay, again, initial and starting just mean the same thing as well. Let's go ahead and take a look at an example of how to solve for velocity. Example 1 says, a dog is running at a constant velocity towards a thrown frisbee. If she runs 21 meters in 1.5 seconds, what was her velocity? Now we're going to go through this step by step. Step 1 is always to write your knowns. I don't care what the problem is, this should always be your first step. Write your knowns. Now, if you're like me, a good visual for this is to highlight any numbers within the problem. So if I'm just looking for numbers to start with, we have 21 meters and 1.5 seconds. Now, what are these things? That's the next thing that we need to identify. 21 meters. Meters is a measure of distance. So we know that she ran a total of 21 meters. Now, since it doesn't give us an initial distance, we can assume that it's 0, and therefore our total change in distance, the total distance that she ran, is 21 meters. Similarly, we can look at that 1.5 seconds and say, okay, it took a total of 1.5 seconds. So the change in time in this case is 1.5 seconds. Okay, now what are we looking for? That's the next thing we need to identify. It says, what was her velocity? So our velocity equals question mark. We don't know what that is. Now we have our knowns, we can figure out what equation we need to use. In this case, we only know one equation. So we're going to go ahead and write our equation without plugging in any numbers. Okay, this is something I will be very particular about. I want you to always write the equation without numbers to begin with. Now, since it's already set up as v equals something else, we can go ahead and plug in our numbers now. So velocity is 21 divided by 1.5. So velocity is 7. And we need to put our units. This is also very important. Miles per hour is very different from meters per second. If you're ever not sure what your units are supposed to be, you can set it up so that your units take the place of the variables instead of the numbers. So distance was measured in meters, and time was measured in seconds. If I plug in the units, we have meters divided by seconds. So the units of velocity for this case would be meters per second. And that's your final answer. Let's go ahead and take a look at another example. Example 2 says, Kevin is running the 50-meter dash at the track meet. If he has an average velocity of 2.5 meters per second, how long was his time? Now, in this case, we're going to be looking for time and not velocity, so it's going to take a little bit more work. But first things first, we're going to always write our knowns. I'm going to go ahead and highlight any numbers in the problem. We have 50 meters and a 2.5 meters per second. It says that he's running a 50-meter dash, so we can assume that his total distance then will be 50 meters. So our total, or change in distance, is 50 meters. It also says he has an average velocity of 2.5 meters per second. Therefore, we can assume that the velocity is 2.5 meters per second. And it asks, how long was his time? So we don't know how long it took him to run those 50 meters yet. We're going to use this information in our equation to solve for time. First things first, always write your base equation by itself. No numbers, no rearranging. Always step one. Start at your baseline, okay? Now we're solving for the change in time. We need to rearrange the equation such that it'll be delta t equals. I'm going to go ahead and multiply that delta t to the other side and get v delta t equals delta d. It's not quite enough yet because I want that delta t by itself. I'm going to divide the v so that I can get that delta t all by itself. Delta t then equals delta d divided by v. Now we're ready to plug in our numbers. Delta t equals 50 divided by 2.5. Delta t equals 20. Now again, if you're not sure what your units are supposed to be for this, we can plug in our units instead. Let's take a look. So we have delta d is in meters, and velocity is in meters per second. The meters cancel, and we're left with 1 divided by 1 over seconds, which is just seconds. Therefore, delta t is equal to 20 seconds, and that is your final answer. Now, the problems that I gave you this week, the last one is a little bit more of a challenge. You need to be careful of what values you're plugging in where. But it's the same process every single time, okay? If you need help, please, please, please reach out, okay? I'm here. I'm on my computer. Ask questions, please.